Thermochemistry, and today we're going to look at thermochemical equations. Thermochemical equation is a chemical equation which includes the energy that's going to be used or produced in a chemical reaction. Every reaction will have an energy change associated with it. That's the reason why chemical reactions happen to begin with, because the molecules are going to undergo a favorable energy change. They're going to be happier after the reaction than they were at the beginning. So, enthalpy. Enthalpy, which is going to be symbolized by a capital H, is a fancy word for the heat content of a substance at a certain pressure. The heat of reaction is defined of the heat that is absorbed or released during a chemical reaction. Nicely named, heat of reaction, the heat that's absorbed or released during a chemical reaction. It makes sense. We're going to symbolize this by a triangle, so delta H will be the change in enthalpy. There are two types of reactions, and remember we've looked at these both. An exothermic reaction, which means that heat's going to be given off. When we did that demonstration with the hand warmer, the reason why that gave off heat is because it was releasing heat, and it was an exothermic reaction. Remember, exothermic, exo is kind of like exit. Heat will be leaving the reaction. So the first way we can look at this is here's our chemical equation, and you'll see that our delta H has a negative sign in front of it. A negative sign means that the reaction is exothermic. Heat is being taken away. When we see a delta H that is a positive, that means heat is a product in an exothermic reaction. So these are both exothermic reactions. We can either look at this as heat is leaving, or we can also look at the heat as being one of the products in the reaction. Notice that these numbers are the same. This is being shown as a product in the reaction. So we not only, with this reaction, this is the combustion of this compound. We're going to get carbon dioxide, water, and it's also going to produce energy. An endothermic reaction can be shown in two ways also. An endothermic reaction will have a positive delta H. The positive sign means that the reaction is endothermic. You're going to need to add heat in order for this reaction to occur. Energy is going to be a reactant. So we can also write an endothermic reaction this way. So we have carbon and sulfur with energy combining to produce carbon sulfide. Again, this is going to be a reactant in our reaction. We have to add heat in order for this reaction to occur. You can think of endo kind of like in. We have to have heat into the reaction in order for it to happen. The heat of reaction, or delta H, is the amount of energy that's used or produced when the coefficient equals the number of moles in a reaction. So the coefficient of any substance is going to equal the delta H. We're going to use this as a new conversion factor. Let's take a look at an example. How much energy is needed when 1.2 moles of sulfur reacts with excess carbon? So our limiting reactant is going to be the sulfur. Here's our equation. Carbon plus sulfur will yield carbon sulfide. You'll notice that our delta H is positive, which means we're going to need to heat this up in order for the reaction to occur. The question is, how much energy is going to be needed? So we have 1.27, that's our known, moles of sulfur. Our unknown is how many kilojoules. We can look at our reaction ratio, our molar ratio. We have 2 moles of sulfur. Will require this amount of energy to be added. So we have 2 moles of sulfur, and now we can use our change in enthalpy to figure out exactly how much energy is going to be needed to cause a reaction of 1.27 moles of sulfur. And it would require 56.7 kilojoules. And that would be the amount that's needed. Let's take a look at another example. How many moles of water would be produced if this reaction gave off 347.1 kilojoules of energy? Well, here's the reaction. Notice that we've got a positive delta H. So our known is that this reaction gives off this amount of heat. So we need to be sure that our sign is negative, because that would make it an exothermic reaction. For every 2 moles of water, that amount of energy is going to be given off. Notice that this is written as heat is one of the products. How much energy is produced when 75.0 grams of oxygen reacts with excess ethanol? Here's the amount of oxygen which we're given. Oxygen, we have 3 moles of oxygen with 1,235 kilojoules being produced. We have to first figure out how many moles of oxygen we have. So 32 grams in 1 mole of oxygen. Now we're going to get our conversion factor. For every 3 moles of oxygen, we're going to have 1,235 kilojoules that is produced. Do the math, and this reaction will produce 965 kilojoules. I can't read numbers today. That's how much it's going to be produced. So let's go ahead and give some of these a try on your own, and we'll demonstrate some more in class.